We'll do miscellaneous exercise of chapter 2. First question. Find the value of the following. Cos inverse of cos 13 pi by 6. Thirteen pi by 6. 13 by 6 two times it goes. So I can write 2 pi plus 1 is the remainder, so 1 pi by 6. Take LCM and check. 6 2s are 12. 12 plus 1, 13 pi by 6 we get, which is equal to cos inverse of, for 2 pi we don't change the ratio, 2 pi plus theta. 2 pi plus theta is the first quadrant angle. In the first quadrant, all trigonometric ratios are positive. So it becomes cos pi by 6. Pi by 6 is in the principal value branch of cos inverse. Principal value branch of cos inverse is closed interval 0 to pi. We can cancel cos inverse and cos. The answer is pi by 6. Second question. Tan inverse of tan 7 pi by 6. 7 by 6 one time it goes, so I can write 7 pi by 6 as 1 pi plus pi by 6. Always after splitting like this, check by taking LCM. 6 plus 1, 7 pi by 6 it gives. Tan inverse of tan of, now we will use tan pi plus theta formula. Pi plus theta is third quadrant. In the third quadrant, tan is positive, so the formula is tan theta. Therefore, it becomes tan pi by 6. Now, pi by 6 belongs to the principal value branch of tan inverse, which is open interval minus pi by 2 to plus pi by 2. We can cancel tan inverse and tan, which gives us pi by 6. Let's do question number 3, which is 2 sine inverse of 3 by 5 equal to tan inverse of 24 divided by 7. LHS is 2 sine inverse of 3 by 5. Any inverse trigonometric function can be changed to any other inverse trigonometric function using triangle method. Opposite side is 3, hypotenuse is 5, so the adjacent side will become 4. Now let us change the sine inverse to tan inverse. I have to write opposite side by the adjacent side. Now let us use 2 tan inverse of x formula. It has 3 formulae, but since the right hand side has tan inverse, we will use tan inverse formula, which is 2 tan inverse of x is tan inverse of 2x by 1 minus x squared. It becomes tan inverse of 2 times 3 by 4 divided by 1 minus 3 by 4 the whole square, 9 by 16. It is 3 by 2 divided by 16 minus 9. 16 minus 9 is 7 by 16. Write the reciprocal. Therefore, the answer is tan inverse of 24 divided by 7. And this is the right hand side to be proved. 4. Prove that sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to tan inverse of 77 by 36. Let us take the left hand side. We will use triangle method and change both of them to tan inverse. Both the values are positive, 8 by 17 and 3 by 5. So first quadrant angle, sine is opposite by hypotenuse. So we can calculate the adjacent side using Pythagoras theorem, which is 15. And here also opposite by hypotenuse, adjacent side will be 4 by Pythagoras theorem. Now the left hand side I am changing both sine inverse to tan inverse. So use the first triangle, it is 8 by 15, and use the second triangle, it becomes tan inverse of 3 by 4. Now let us use tan inverse of x plus tan inverse of y formula. I am writing the formula. And we have a condition for this formula, xy is less than 1. Check whether the condition is satisfied. Yes, it is satisfied, because 8 by 15 into 3 by 4. 6 by 15 is less than 1. So I can use this formula. Tan inverse of x plus y. So 8 by 15 plus 3 by 4 divided by 1 minus x into y. 8 by 15 into 3 by 4. Take LCM and simplify. (32 plus 45 by 60 minus 24. LCM's 15 into 4 will get cancelled. We get tan inverse of 77 divided by 36. And this is the right hand side. Question 5. Prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. Two methods are there. We can use substitution method or changing it into tan inverse using triangle method. Cos is adjacent by hypotenuse. 4 by 5 is a positive value, so first quadrant angle. The opposite side will be 3 by Pythagoras theorem. In this triangle, 12 by 13, the opposite side will be 5 by Pythagoras theorem. Now we will change both cos inverse to tan inverse using this triangle. Tan inverse of opposite by adjacent. Similarly, cos inverse of 12 by 13 will be same as tan inverse of 12 by 5 by 12. Now let us use tan inverse of x plus tan inverse of y formula, which is tan inverse of x plus y by 1 minus xy. Check whether xy less than 1 condition is satisfied or not. 3 by 4 into 5 by 12. 5 by 16. Yeah, it is less than 1. We can apply this formula here. So tan inverse of 3 by 4 plus 5 by 12 divided by 1 minus 3 by 4 into 5 by 12. Let us take LCM and simplify. 3 12s are 36, 5 4s are 20, divided by 4 12s are 48, minus 15. LCMs I have cancelled. Therefore, the answer is 56 by 33. But the answer, required answer is cos inverse of 33 by 16. So let us change our answer in terms of cos inverse. Again triangle method. Acute angle again. First quadrant angle because the value is positive. Tan is opposite by adjacent. So use Pythagoras theorem. The hypotenuse will be 65 because it is root of 33 square plus 56 square. Now change tan inverse to cos inverse, which is adjacent side by the hypotenuse, and this is the right hand side. Question 6. Prove that cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of 56 by 65. So we can use the same previous questions method, changing it in terms of tan inverse and using tan inverse of x plus tan inverse of y formula, or we may use substitution. I will explain substitution method for this. So let us take cos inverse of 12 by 13 as A and sin inverse of 3 by 5 as B. So the left hand side is A plus B, and on the right hand side we have sin inverse, so we will find sin of. We have sin inverse here, therefore we are finding sin of A plus B. Sin of A plus B formula is sin A cos B plus cos A sin B. Now we will use triangle method. So from this, cos A is 12 by 13, and from this sin B is 3 by 5. So using triangle method, we can calculate sin A. Cos is adjacent by hypotenuse, therefore opposite side is 5. And here also triangle method. Sin is opposite by hypotenuse, so adjacent side will be 4. Now sin of A plus B is equal to sin A. From this triangle, sin A is 5 by 13, opposite by hypotenuse. Cos B from this triangle. For B you have to refer the second triangle. Cos B is adjacent side by hypotenuse plus cos A. Again first triangle. From the first triangle, cos is adjacent by hypotenuse, and sin B from the second triangle, or here we have sin B direct value, so 3 by 5. (20 plus 36 by 65). The answer is 56 by 65. So A plus B is sin inverse of 56 by 65. That is taking sin inverse on both sides. Now substitute for A and B. Our A is cos inverse of 12 by 13. B is sin inverse of 3 by 5, and we have proved that, which is equal to sin inverse of 56 by 65. So you may use this substitution method or changing them to tan inverse and using tan inverse of x plus tan inverse of y formula method. Question 7. Prove that tan inverse of 63 by 16 is equal to sin inverse of 5 by 13 plus cos inverse of 3 by 5. We will take the right hand side. sine inverse of 5 by 13 plus cos inverse of 3 by 5. We will use triangle method, change them to tan inverse. The values are positive, so first quadrant angles. Sine is opposite by hypotenuse. We can calculate the adjacent side is 12. Here again triangle method. Cos is adjacent side by the hypotenuse, therefore the opposite side will be 4 by Pythagoras theorem. Now we will change both of them to tan inverse. So the first one from the first triangle, sine inverse of 5 by 13 becomes tan inverse of 5 by 12 plus tan inverse of, from the second figure, it is 4 by 3. Now let us use tan inverse of x plus tan inverse of y formula. Which is tan inverse of x plus y by 1 minus xy, and the condition is xy should be less than 1. Check whether the condition is satisfied. 5 by 12 into 4 by 3. Yeah, it is less than 1. So we can use the formula tan inverse of 5 by 12 plus 4 by 3 divided by 1 minus 5 by 12 times 4 by 3. Let us take LCM. LCMs will get cancelled. 15 plus 48 divided by 36 minus 20. Therefore the answer is tan inverse of 63 by 16, and this is the left hand side. Question 8. Prove that tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8 equals pi by 4. Let us combine these two terms and these two terms and use tan inverse of x plus tan inverse of y formula and check whether the conditions are satisfied. The condition is xy should be less than 1. So the conditions are true here. Therefore the left hand side becomes, let us combine the first two. 1 by 5 plus 1 by 7 divided by 1 minus 1 by 5 times 1 by 7. Combine the last two terms. 1 by 3 plus 1 by 8 divided by 1 minus 1 by 3 into 1 by 8. Take LCM and simplify. 7 plus 5 by 35 minus 1. Cancel the LCMs. Tan inverse of 8 plus 3, LCM will be 3 into 8. 24 minus 1. This is 12 by 34. Tan inverse of 11 by 23. And here we can simplify. I can cancel 2. So if you do with smaller numbers, the calculations will be easier. So it is better to simplify and do it. Again use the same formula, tan inverse of x plus tan inverse of y formula. Again check the condition. Condition is satisfied here. 6 by 17 into 11 by 23 is less than 1. So tan inverse of x plus y by 1 minus x into y. Tan inverse of 17 into 23 is the LCM. 138 plus 77, 7, 187 divided by 17 times 23. It is 193 minus 66. Tan inverse of, let us add 325 divided by 325. The answer is tan inverse of 1, and tan inverse of 1 is pi by 4, and this is the right hand side. Question 9. Prove that tan inverse of root x is equal to half into cos inverse of 1 minus x divided by 1 plus x, where x belongs to closed interval 0, 1. I can take the left hand side, tan inverse of root x. Let us multiply and divide by 2. So tan inverse of root x, I am multiplying by 2, so I have to divide by 2. Multiply and divide by 2. Half into 2 tan inverse of x, we have formula. 2 tan inverse of x is cos inverse of, the answer is in terms of cos inverse, so I am using cos inverse formula. It is 1 minus x square divided by 1 plus x square, where x is greater than 0. Here root x is greater than 0, so we can apply this formula. It becomes cos inverse of 1 minus root x square by 1 plus root x square. One minus x by 1 plus x, which is the right hand side. Or you may take the right hand side and prove the left hand side also. Question 10. Prove that cot inverse of root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x equal to x by 2. X belongs to open interval 0 to pi by 4. We have so many methods to do this question. The easiest of all is conjugate method. We don't need any substitution here because already we have trigonometric function inside the bracket. Outside we have inverse trigonometric function plus root of 1 minus sin x. I am rationalizing the denominator. I have to multiply both numerator and denominator by root of 1 plus sin x plus root of 1 minus sin x. So same term in the denominator. Cot inverse of, the numerator has the same terms, A plus b into a plus b will become a plus b the whole square. So root of 1 plus sin x plus root of 1 minus sin x the whole square divided by denominators of the form a plus b into a minus b, which will become a square minus b square. When you square, root will be removed. Let us simplify further. A plus b the whole square formula, I am expanding a square plus b square plus 2 times ab. So both are under root. I can multiply and write it under one root. 1 plus sin x into 1 minus sin x becomes 1 minus sin square x divided by sin x minus of minus plus sin x. So 2 sin x. Cot inverse of 1 plus 1 is 2. 1 minus sin square is cos square. Root of cos square is cos x. We can take 2 common and it gets cancelled with the denominator 2. Now we have 1 plus cos formula we know. Wherever you see 1 plus cos or 1 minus cos, use those formulae. So 1 plus cos x is 2 cos square x by 2. Plus sign has cos square formula, minus sign has sin square formula. Similarly, sin theta formula, 2 sin theta by 2 cos theta by 2. So 2 sin x by 2 cos x by 2. So that we can simplify the function. It becomes cot inverse of cos x by 2 by sin x by 2 will be cot x by 2. We can cancel cot inverse and cot if x by 2 is in the principal value branch. It is given that x belongs to open interval 0 to pi by 4. So x by 2 will belong to divide by 2, pi by 8, which is the subset of the principal value branch of cot inverse. Cot inverse principal value branch is open interval 0 to pi. So we can cancel cot inverse and cot because x by 2 belongs to the principal value branch. The answer is x by 2, which is the right hand side. Question 11. Prove that tan inverse of root of 1 plus x minus root of 1 minus x divided by root of 1 plus x plus root of 1 minus x equal to pi by 4 minus half cos inverse of x we have to prove. And the condition given is minus 1 by root 2 less than or equal to x less than or equal to 1. Since we have root of 1 plus x as well as 1 minus x, we will go for cos 2 theta substitution. We will substitute x as cos 2 theta. Therefore, LHS will become tan inverse of root of 1 plus cos 2 theta, root of 1 minus cos 2 theta divided by root of 1 plus cos 2 theta plus root of 1 minus cos 2 theta. In this question, we are using trigonometric substitution, whereas in the previous question, already we had trigonometric function, so we didn't use any substitution. Since we have inverse trigonometric function outside, we need a trigonometric substitution so that it can be simplified. Tan inverse of 1 plus cos 2 theta formula is 2 cos square theta. Very, very important formula. Root of 1 minus cos 2 theta is 2 sin square theta. Minus sign has sin square formula, plus sign has cos square formula. Similarly, this is root of 2 cos square theta and plus root of 2 sin square theta. Tan inverse of root 2 is common, we can take it out. Root of cos square is cos theta minus sin theta divided by, here also root 2 is common in the denominator, so cos theta plus root of sin square is sin theta. Now we need 1 in this position to use tan inverse of x minus y by 1 plus xy formula. So we need 1 here. To get 1, let us divide by cos theta. Each and every term inside the bracket should be divided by cos theta. We get 1 minus sin by cos becomes tan. This becomes 1 plus tan theta. In the denominator, I can write tan theta as 1 into tan theta. And this is of the form tan inverse of x minus y by 1 plus xy. I can write this as tan inverse of x minus tan inverse of y formula. So tan inverse of my x here is 1. In place of x I have 1. And in place of y I have tan theta. So it becomes tan inverse of tan theta. Tan inverse of 1 is pi by 4. And tan inverse of tan will become theta if theta is in the principal value branch. So we have to check whether theta is in the principal value branch or not. Now substitute for theta. Theta is half cos inverse of x. See here, from this 2 theta is cos inverse of x and theta will be half cos inverse of x. That's how we substituted theta as half cos inverse of x. Now let us check whether it is in the principal value branch or not, theta. So I have to check the condition. In this question, the condition given is minus 1 by root 2 less than or equal to x less than or equal to 1. And our cos theta is, x is cos 2 theta. We used this substitution. Take cos inverse throughout. So 2 theta, and here cos inverse of 1 is 0, and here cos inverse of minus value is the second quadrant angle. So pi minus 45 base angle, which is 3 pi by 4. Principal value branch for cos inverse is closed interval 0 to pi, so I have to write the second quadrant angle, and I have to reverse the inequality. You can make out from the values itself, 0 here and 3 pi by 4 here. Okay, now I have to substitute, check for theta. So let us find theta. Divide throughout by 2. So 3 pi by 8 and 0 by 2 is 0. 3 pi by 8 is 135 by 2, which is the first quadrant angle. So this is in the first quadrant. Theta is in the first quadrant, so I can cancel. Tan inverse and tan could be cancelled. because it is in the principal value branch.